Hi there, and welcome to, let's see, this is Math Foundations Pre-Calculus 10. This is our first chapter, and this is, I'm thinking it's video number 3 on squares and square roots. And by now, you should be really good at prime factorization. We're going to use that in a little bit. Okay, so what is special about those numbers? I'm not really sure. Hold on a sec. Whoops, sorry about that. Once again, you can tell from background, I am recording at school, so things happen. Okay, back to our numbers. You've had a moment to think, and maybe you have an answer. Maybe you recognize them as perfect squares, and I'm going to make a nice little chart. Whoopsies, I'm making a mess. So okay, so remember exponents, that means I'm going to multiply. The 2 says I'm going to multiply something twice, so this means 1 times 1 is 1. This means 2 times 2, which is 4. This means 3 times 3. Oopsies, don't do that. Put a 9. And this is 4 times 4, which is 16. I'm going to stop writing that because you know what it means. 25, 36. You'd be amazed the number of people that think 49 is a prime number. And now you are not one of them anymore. 49 is 7 squared. 64, 81, and 100. So all of these are what we call perfect squares. All right, so sketch each number. My apologies if you started this on your own and you looked at it and you went, what? So 9, what I'm trying to get you to do is you can make it pretty. You can make it nice. There. That's why it's called a perfect square, because if you have that many dots, you can arrange them to make it all nice and pretty. So 25. And it's going to be a 5 by 5 grid. All right, 16. Now I could go like 4, 5, 6, 7, 8. And I mean, that's not wrong, but that's not showing it's a perfect square. I'm going to cross it out anyway. For the purpose of where I'm going, whoops, 4 is enough. So it's 4 this way, and 4 this way, and 16. Okay, now I'm going to cheat. And you're probably happy that you're watching the video. So for 64, it would be 8 this way, but 8 this way. I am not drawing 64 little dots. I love my job, but not enough. So if we do 8 by 8, we'd have that. And then 100 would be a nice little box with 10 dots that way. 10 dots. Oh, I can do that. 1, 2, 3, 4, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. Sorry, I'm counting out loud. There you go. So if I filled all that in, you would have 100 dots, and it's a 10 by 10. Ta-da! All right, next part. What is the difference between squaring a number and square rooting a number? Okay, so squaring is multiplying a number by itself. So 5 squared. And you can also think of it almost as when you have the exponent of 2. 2, you can say 5 to the power of 2, but most people just say 5 squared. Means 5 times 5 is 25. Ta-da. Okay, we're square rooting a number. This means what number times itself gives the original number. And if we want to kind of stick with this, the square root of 25 is 5. Because 5 times 5 is 25. Ta-da! All right. Now, I know you can use your calculator to do this, but on your test, it's going to say, show me, prove to me, maybe use prime factorization to demonstrate the square root or something. Something like that. Okay, so here's what I'll let you do. Surprise, surprise, surprise. We're going to start by treeing out the number. 4 and 4, 2 and 2, and 2 and 2. So when we're doing a square root, we circle the pairs. There's a pair of 2s, and there's a pair of 2s. So careful, this is only one number at a time. It's not greatest common factor where you're circling a 2 in this one and a 2 over there. Nay, 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 nay. This is just in the same one. So we're looking for pairs, and then 1 from each pair. You multiply it together, and you get 4. And some of you may be saying, I know, I could have told you that in the first place. The square root of 16 is 4. Yes, but now we've proved it. And that becomes helpful when later on we start throwing variables in. So if you can do it with numbers, variables is a no-brainer. All right, and this is kind of the chapter on prime factorization. So let's go 4 times 9. Oh, this will look pretty. 2 times 2 times 3 times 3. I kind of picked those factors, so it would look nice. So 2 times, gonna check. 2 times 2 is 4, times 3 is 12, times 3 is 36. So we're good. Circle my pair, circle my pair. 1 from here comes down, 1 from here comes down, which leaves me a grand total of 6. So that is the same thing as if, whoops, I guess I should have had a square root sign here and there, there, and there. All right, at this point, I pretty much think you should pause the video, do those. They're not very hard. Oh, by the way, I know you paused the video to do it yourself. Circle, circle, from there, from there, 9. So 10 times 10, 2 and 5. This is Joanne being a little weird and fussy. I'm going to arrange these. It's never wrong to rearrange your numbers in ascending order. It's just, for me, it makes it cleaner, and maybe it's just making it easier to teach. Just like that, at 2 and at 5, and that gives me 10. If I wanted to be all fancy and lazy, remember, it's any set of factors. So I could have went 4 times 25, 2, 2. Still get the same thing. It was just prettier. Didn't have to rearrange it. Oh, what did you notice? Well, the square root. Ta-da! And that's the end of the video. One more to do, and this chapter is done. Have a spectacular day, evening, morning, lifetime if you want. Bye!